Hello, geometry. So we are talking about angles of triangles. All right. So we learned already about how to name triangles based upon angles and their sides, and then how we can use that information to solve for variables. Today we want to talk about interior angles. So, for example, angles interior we know means inside, right? So angles that are inside a triangle. So angle A, angle B, angle C would be one way of saying that. Angle A we could also name angle BAC or angle CAB, right? That's all angle A. So those are on the inside of the triangle. And I will try and highlight those with red so we could see them. Exterior angles. Now, if we were to take our sides here and just elongate them, our exterior angles would be these ones right here. All right, it would be these angles. Those are exterior angles. Now, why do we care about those angles? Well, because the exterior angle plus the interior angle, they form a straight line, so they make 180 degrees. So that can be useful for some of the stuff that we do. Now, triangle sum theorem. The triangle angle sum theorem, I should say. The sum of the interior, all right, the interior angles of a triangle is 180 degrees, all right? So if we add the measure of angle A plus the measure of angle B plus the measure of angle C, we're going to get 180, all right? It adds to make 180. For our next one here, I'm going to slide this guy up. Exterior angle, all right? An exterior angle is formed by the line of one side of the triangle. The extension, I think, of one side of the triangle. The measure of an exterior angle is equal to the sum of the two non-adjacent interior angles. So here's what I mean by that. If this is the exterior angle, angle 1, that means it's going to be equal to the measure of angle 2 plus the measure of angle 3. So this angle equals those two added together. So kind of weird and cool. How do you know that that's true? Well, we know that all three of these would equal 180 total, and we know that this angle plus that angle is going to equal 180. And therefore these two must equal that. So it's a whole process. If you want me to show you the proof, I'm happy to do that. It's pretty cool how you can substitute and it remains true. So the corollary to the triangle sum theorem, a corollary is a statement that can easily be proven true using a theorem. So the acute, right? The acute, so the small angles of a right triangle are always, they equal 90 degrees. So not supplementary, but complementary. Sorry about that, guys. Blocked my video there for a second. Here, I will move this up here so it doesn't happen again. Ooh, and you can't see that. That's also terrible. So, a corollary is a statement that can easily be proven true using a theorem. All right, you don't have to worry about that so much, but just know corollaries are based upon theorems. All right, which means that they are true and valid and robust. The acute angles of a triangle, right triangle, are always complementary. All right, so if we know this is a right angle, then angle A plus angle B is going to be 90 degrees. All right, so the handy theorems to have on hand that we're going to be using. So for our first one, right up here, we want to find all of the missing angles. Okay, we want to find all of the missing angles. Well, we know that all of the interior angles add to make 180. So I don't have any points here. That means I can just write down 24 plus angle 1 plus 37 is going to add to make 180. So I'm going to combine my like terms. So angle 1 plus 61 is equal to 180. I need to subtract 61 on both sides. That means angle 1 is equal to 119. All right, 119. All right, for number 2 here, we are looking for the measure of angle 1, and we've been given 2 non-adjacent interior angles. Well, we just said that angle 1 is going to equal the sum of these 2 angles. So all I have to do is add them together. So we get 128 for our angle measure. All right, for this one right here, we are looking for the measure of angle 1. Now, here's where it gets a little trickier. Our exterior angle is 104 degrees. It's going to be equal to angle 1 plus 79. All right, so setup is key. All right, setup is key. So subtract 79 on both sides, and we end up with 25 is the measure of angle 1. I'm going to give you a kind of handy spot up there to write it. All right, for number 4 right here, we have kind of 3 different triangles, right? If we cover this up, that's a triangle. If we cover this up, that's a triangle. And then this whole big one right here is also a triangle. Let's just start with angle 1, and we'll see if we can find its measure. So ignore what you don't need, right, which is all of that. So we know that we have an angle 1, 66 degrees, and then an 84 degrees. So those are all interior angles. That means angle 1 plus 66 plus 84 is going to equal 180. So that means angle 1 plus 66 plus 84 is 150. If I subtract 150 on both sides, then we get angle 1 is equal to 30 degrees. So now we need to figure out angles 2 and angle 3. I'm going to focus on angle 3 next, and the reason for that is because if we ignore kind of that right there, then we can see that this now looks like this, which means 84 is an exterior angle. So angle 2 plus 43 will equal 84. The other thing I can do too is 84 plus angle 3, they are supplementary. They form a straight line, a linear pair. So that will also equal 180. So we have many different ways of doing this. So I'm going to do 84 plus angle 3 is equal to 180. When I subtract 84 on both sides, I end up with angle 3 is equal to 96. And then the other one I'm going to do is that exterior angle theorem. So that would be 84 is equal to angle 2 plus angle plus 43. All right, because those are the 2 non-adjacent angles, those 2. Because 3 is right next to it, it's adjacent. So we want non-adjacent. So when I subtract 43 on both sides, we get 41 is the measure of angle 2. So angle 2 is 41, and then angle 3 is 96, 96. All right, for 5 right here, all right, we are looking for the measure of angle 1, 2, and 3. And again, we've got this little triangle here, then we've got a slightly bigger triangle up there, and then we even have this as a triangle. Okay, so we have many, many different ways of doing this. I'm going to start by trying to find angle 1. So I'm going to ignore everything I don't need. I can see that that's a right triangle. What does that little thing mean again? 90 degrees. So we know the interior angles are all going to add to make 180. So angle 1 plus 43. The other thing we know too is we learned about that corollary just now, which said that if we have a right triangle, then the 2 acute angles add to make 90. So angle 1 plus angle 43 plus 90 equals 180, or I'll make it a little easier myself. Those 2 make 90. All right, so there are multiple ways to do this. I like to be efficient, not lazy, efficient. So I subtract 43 on both sides. We get angle 1 is equal to 47. And then we need to figure out the measure of angle 2 and the measure of angle 3. Well, for the measure of angle 2, if I ignore these guys, that looks like an exterior angle. So measure of angle 2 is going to equal the measure of angle 1 plus this 90. The other thing I can do is I can just set those 2 they are a linear pair, so I can add them and make them equal to 180. It doesn't matter, you'll get the same answer. Since I did the sum the last time, I'll do the 180 this time. So 43 plus angle 2 is equal to 180. So angle 2 is equal to 137. And then our last one right here is angle 3. Again, there are many ways to do this. I'm just going to choose to add angle 2 and 3 and 12. Because that makes 180. Angle 2 we know is 137. So that's really 37 and 12 makes 149. When we subtract 149 on both sides, we end up with angle 3 is equal to 31. All right. Let's look at these some more. All right, because I need to remind you of some of these. And it's always good to practice. We're going to do the rest of these together too. So for angle 1, for number 6 here, we've got 2 other angles in our triangle. So I'm just going to use the triangle sum theorem, which says that angle 1 plus 61 plus 68 is equal to 180. So that means angle 1 plus 129 is equal to 180. When I subtract 129, we get angle 1 is equal to 51. For angle 2 down here, this one, hopefully you guys can recognize it. We spent a lot of time talking about it, and I told you it was going to come up over and over and over again. We know our angle pair relationships. Angle 2 is vertical angles with 61. Vertical angles, why do I care? Vertical angles are congruent. So that means 61 is equal to angle 2. So angle 2, 61. Hey, look at that. Wasn't that nice? Didn't have to do any math. Just flat out equal. They're congruent. Which means we are down to angle 3 right over here. Now I'm going to use my corollary to the triangle sum theorem, which was that angle 2 plus angle 3, because this is a right triangle, is going to equal 90 degrees. Now we know angle 2 is 61. So I can subtract 61 on both sides, which means angle 3 is going to be equal to 29. Right? And that is our answer. All right, for number 7 here, BC bisects angle ACD. All right, we have to remember what that means. Why do I care? Bisect. Bi, two, sect, sections. What's purposeful? What's important about those 2 sections? They're congruent. So BC bisects angle ACD. That means angle 2 and angle 3 are congruent. 2 is congruent to angle 3. So once I find the measure of one, I know the measure of the other as well. Now, here's the cool thing too. If they are congruent, and this is a 45-degree angle, or excuse me, if this is a 90-degree angle, then they must be 45. Well, gave that answer away, sorry. So these are both 45 degrees. Why? Because angle 2 plus angle 3 equals 90. If they are both x, then 2x equals 90, so we divide by 2, so x equals 45. So they are both 45 degrees. All right, I'm going to take a look at my triangle ABC up here. So that's got a 48-degree angle plus angle 2 plus angle 1. It's going to equal to 180. So I'm just ignoring that one, looking at the top. Angle 2 we just said was 45. So 48 plus 45 plus angle 1 is equal to 180. So that would be 93. When I subtract 93 on both sides, we get angle 1 is equal to 87. And then we need to figure out this one down here. We already know angle 3, so we need to figure out angle 4. So angle 4 plus angle 3 plus 83 equals 180. Angle 3 we said was 45. So angle 4 plus 45 plus 83 is equal to 180. 45 and 83 make 128. When I subtract that on both sides, sorry, my handwriting is getting kind of small to read, but hopefully you can hear me just fine. So that would be 52. Angle 4 is 52 degrees. All right, this one is the next one right here. And it says L is parallel to M. If you know it, mark it. You saw me do that with the bisect up here, right? I marked that those angles were congruent with my one Wuxi. So that means I need to put my little arrows here so I know that they are parallel. All right, I need to know that they're parallel. Now, why do I care about parallel lines? Oh, because look, we've got a transversal right here. So if I ignore those things and I look at my transversal, 49 degrees and angle 4 actually have a relationship. They have a relationship. Do you guys remember what that is? What is their relationship? Oof, sorry, this thing's in my way. There we go. Well, they are on the inside, so they're going to be interior, right? Which means they're either consecutive interior, same side of the transversal, or alternative, right? Alternate interior. Now, one is on the right, one is on the left, so these must be alternative. That means if they are alternative interior angles, then angle 4 is congruent to 49 because they are alt-int angles. So that means angle 4 is 49 degrees. Hey, look at that. We didn't have to do any math. Just plugged it right in. Isn't that nice? All right, for our next one, trying to see what other ones that we have here that are easy. Oh, we can ignore this guy. All right. We can ignore that guy. So our transversal is this guy now. And if we look at it, we know a 73 degrees. So 73 has a relationship with angle 1, right? They are both interior. Are they consecutive or are they alternate? Alternate or consecutive? They are another pair of alternate interior angles. So that means angle 1 is congruent to 73. Okay, so why do I care about that? How does that help? Well, now that we know that, we can actually figure out what angle 2 is, because all to add up to make 180, right? Angle 1 plus angle 2 plus 49 is going to equal 180. How do I know that? Because it forms a straight line, and straight lines are straight angles, which are 180. So angle 1 we know was 73 plus 49 plus angle 2 is equal to 180. So that would be 122. So when I subtract 122 on both sides, there we go. Angle 2 is equal to 58. All right, angle 3. Angle 3 is an exterior angle to angles 1 and 4, or 2 and 4, excuse me. So we could do, because it's an exterior angle to this triangle right here, we can do angle 2 plus angle 4 is equal to angle 3. Well, angle 2 we said was 58. Angle 4 was 49. So that would be 107 is equal to angle 3. And then angle 5. Angle 5 is actually exterior to this triangle as well. So angle 5 should be equal to angle 2 plus angle plus the 73 degrees. The other thing, it's a supplementary to angle 4. So you can do it either way. Since we just did an exterior angle, I'm going to choose to do the supplementary. So angle 4 plus angle 5 equals 180. Angle 4 we said was 49. So if I subtract 49 on both sides, we get that angle 5 is equal to 131. So it's really important that you don't skip steps, that you have your setup. That's really key. Setup is really key. I'm going to move the page now. And I want you to try some of these, all right? So I'll leave these ones posted up here so you can see all of them. You want to solve for x. All right, you want to, ooh, we haven't really done that, have we? All right, let's do this one together then. We'll do this one together. So for this one, we have 2 angles in the exterior, so we can use that exterior angle theorem, which says that 151 is going to be equal to these angles added together. So 20x plus 3 plus 11x minus 1. I'm going to do my like terms. So 151 is equal to 20x plus 11x is 31x. Positive 3 minus 1 is a positive 2. I can subtract 2 on both sides. So now I'm at 149 equals 31x. When I divide by 31 on both sides, I get 4.8 is equal to x. Technically, it'd be 149 over 31, but I will allow you to round it to a decimal in this case. For this one, we have a triangle sum theorem here along with this one, right? So they all add to make 180, and then you're just solving. So take a minute to try those out. Pause the video. All right, and then down here, we want to solve for x and y. So we'll do this one together as well. So first thing I want to do is I notice that I have an angle here, and its vertical angle is right there. So that means this angle is also 11x minus 9. Well, why does that help me? I have 3 angles for this triangle, 6x minus 2, 72, and then 11x minus 9. I know that all of these are going to add to make 180. So I'm going to just find my like terms. I'm going to use some color this time. It helps my brain better than all gray. So 6x plus 11x is 17x. And then negative 2 plus 72 is 70. Minus 9 is 61. So I need to subtract 61 on both. I get 17x is equal to 119. When I divide by 17, I get 7. Now that I know what x is, I can solve for my y over here. So this is another triangle sum theorem. So 11x minus 9 plus 5y minus 8 is plus 30 is equal to 180. But x is really 7. So this is really 11 times 7 minus 9 plus 5y minus 8 plus 30 is equal to 180. So 11 times 7 is really 77. I'm just going to leave my 5y there. So I'm going to have 77 minus 9 is 68. Minus 8 is 60. Plus 30 is 90. So it's really plus 90 equals 180. When we subtract 90 on both sides, we get 5y is equal to 90. When I divide by 5, I get y is equal to 18. So I found my x was 7, my y was 18. There are some more problems right here for you to practice. I want you to know right now that this should have been marked for you, that these are parallel. All right, that needed to be marked, and it wasn't, because you can't assume it. All right, please let me know if you have any questions on this. I highly encourage you to solve these and to practice these. All right, I highly encourage you to solve these and practice these.